GCSE mathematics topic by topic. This time we're going to have a look at Pythagoras and trigonometry, which you'll find sort of not too bad. They're not really that bad, but it takes a bit of getting used to. So let's get down and have a look at, first of all, Pythagoras. Now, Pythagoras requires us to have a right-angled triangle. So let's just put in a very simple one. Now, the trigonometry we're also going to look at today is also going to be based on a right-angled triangle. Okay, so there we've got our simple triangle, and let's give us some simple sides, and we'll do a simple example to start with. So I've got a side 3, I've got a side 4, and we've got to determine what this side is. The relationship for Pythagoras is the square on the hypotenuse, this side, is equal to the sum of the two squares on the opposite sides. So if I want to work out hypotenuse, h, we're going to say that that is going to be equal to the square root of 3 squared plus 4 squared. Let's just zoom in a little bit. There we are. Probably a bit easier to see. Now, 3 squared is 9. 4 squared is 16. 9 and 16 make 25. And the square root of 25 is 5. So in all these cases, that's h. And so we've worked out this particular triangle. And this is called a Pythagorean triplet because they are whole numbers. Let's do another one, which is also one of these triplets. Again, we've got a right-angled triangle, but it's a slightly different shaped triangle, and it's sort of much longer and thinner. And we'll put in our right angle, which I didn't do last time, and this side is 12 and this side is 5. So again, we're going to work out what the hypotenuse is. So simply it's going to be the square root of the other two sides, 5 squared plus 12 squared. 5 squared is 25, 12 squared is 144, add those together, it gives us 169, and the square root of 169 is 13. So Pythagoras, not that difficult, but let's look at one where you might have a different problem to try and solve. And a problem that you might have to solve might be one where we've got not such nice numbers, and as well as not having such nice numbers, we might have a different problem that they might give us the hypotenuse this time. So let's give us a hypotenuse. We'll make up a number, 21. And this side is going to be, we'll say 15, and I want to work out what this side is going to be. Now for this we're going to need a calculator to try and help us. We know that here 21 is going to equal, well, 21 is going to equal, yeah, we'll do it this way, is going to equal 15 squared plus whatever that is squared. Let's get rid of this square root by squaring both. So we can also say that 21 squared equals 15 squared plus question mark squared, and if I rearrange that, I've got 21 squared minus 15 squared is going to give me this side that I don't know squared, and so we can square root both of those, and that gives us our answer. What we could have just done was simply have written down 21 minus the other one. So if you've got the hypotenuse, we're going to use minus one of the other sides to find out the other side. All I need to do now is this equation, so let's put it in. So I've got the square root of here, which is going to be 21, that was no help, was it? 21 squared minus 15 squared, and that's going to give us minus 204. Don't think that went right somehow. I'm going to go back and do that one again. I'm going to put some brackets in. That's what went wrong with this one. So let's just put in some brackets. Sometimes calculators do cause a few problems when you don't expect them, and what you would expect to do and what necessarily the calculator will expect is slightly different. There it looks right because I've got the square root over the whole lot, and we can work that one out, and it gives me a horrible number, 6 root 6, which is not really what I want because I don't need this exact. So we're going to look at it pressing the third to decimal number, and that's going to give me 14.696, and if we take that and we round that, that's going to give us 14.7 as our answer. So Pythagoras, not too bad, but it does give us this problem with the calculator, and you have to notice that when you're going to do this, that sometimes you've got to put in a few extra bits and pieces for the calculator, such as brackets, and then the problem gets solved. So there is simple Pythagoras. I'm not going to do any more of those because what I want to do is move on and have a look at the one that causes all the problem, which is trigonometry. Trigonometry is really just playing around with this a little bit more, but this time we're going to try and find the angles, or in fact if we've got an angle we can find a side. So let's draw in a little triangle. There are 3 different equations that we need to know to do trigonometry. So we've got our triangle. Let's give ourselves an angle, and we'll put some figures in for here in a moment. This side is our hypotenuse. This side here is as far away as I can get from the angle. This is the opposite angle, and this line here is next to the angle, or we call it adjacent to the angle. Yeah, I wasn't looking at what I was doing on the screen, was I? So opposite, adjacent, and hypotenuse, and this is my angle that we're going to be working out, x degrees. We need to learn something to try and solve this, and this is normally called SOHCAHTOA. let's break this down, that we've got the SO, that is the sine of an angle, and that equals the opposite over the hypotenuse. We've got K, this is the cosine of an angle, and this is the adjacent over the hypotenuse. And then we've got TOA, this is the tangent, and this is the opposite over the adjacent. And we've got to learn these bits and pieces. I think I may have zoomed in a little bit too much. Let's zoom out just a tad. That's better. Then you can see all the things that I'm writing. Now, let's try this out on a particular problem. Now, there's one other factor we need to know, that if we're working to find a side, then we'll use on the calculator the buttons sin, cos or tan, short for sine, cosine and tangent. If you're finding an angle, then we will use the sine -1 button, or the cos -1, or the tan -1. And these are found on the calculator by pressing the shift button. So if I do sine, I get the sine, but if I want to do the sine -1, I press shift and then sine, and it comes up with sine -1. Otherwise sometimes known as the arc sine, arc cos, arc tan. Let's delete this and let's have a look at a particular problem. Every time you get a problem using these trig functions, then almost without exception they are in calculator papers. There are some odd exceptions when we've got to learn some more trigonometrical ratios, but more of that later. Let's have our angle, and we'll shove this one in as 30 degrees. We'll have here this side, we'll put this one as 15, and I want to determine what is this side. We can call it X if you like. My first stage when I do this is I'm gonna, having drawn the triangle, that will come in the paper usually, or the question. So the first thing we're going to do is we're going to label it. We're going to put in the hypotenuse, we're going to put in the opposite, which one is opposite the angle, and we've got the adjacent. Now what I want to do is I want to work out which one I'm trying to do. Well, let's see what we want. We've got an angle, I've got the hypotenuse, and I want to find the opposite. So I don't want the adjacent. So in fact I can put my finger over there and cover that up and see that yes, I've got the hypotenuse, I've got an angle, and I've got to find this side. So let's look at our writing down of our SOHCAHTOA. So I've got an angle, so I've got the sine, the cos or the tan. I've got the hypotenuse, so it can only be one of those two, and I've got the opposite, so it's going to be SO. So we know that the sine of my angle, the sine of my angle 30, is going to be the opposite divided by the hypotenuse. Let's put in what those are and rearrange the formula. So the sine of 30 is going to be the opposite, which I don't know, divided by the hypotenuse. We're going to rearrange this formula, and I need to get rid of this divided by 15, and to do that what I'm going to do is I'm going to multiply both sides by 15. This will cancel, and so we've now got 15 times the sine of 30 degrees equals the opposite. Let's go and put this into the calculator. So I've got 15 times the sine of 30 degrees. I'm going to close my brackets. You will be amazed you can get away with not putting the brackets all the time, but it doesn't always work. And that gives me the answer 15 over 2, which we're going to say is going to be 7.5. And I've calculated that side. Okay, let's go and have a look at another one. Sometimes, to confuse you, they won't give you the drawings the right way round, but what they will do is they will put them a different way. All you've got to do is look at the problem and see what you need to try and solve. So this side is the hypotenuse. Here, let's have our angle X that we're going to have, and this time let's make the angle X equal 25 degrees, and I'll have a hypotenuse which is 20, and we've got to work out what side Y is. So we can label these sides. This is opposite angle, this is the adjacent. We just have to look at this is next to the angle. The hypotenuse is always the longest side, and the opposite is always as far away you can get from the angle. So we've labelled it. We know we've got to do SOHCAHTOA. Work out what we want to do. So we've got the angle, we've got the hypotenuse, and we need to find the opposite. So our adjacent we don't want. We're not interested in that one this time. So I've got an angle, sine, cos or tan. Got the hypotenuse, it's only going to be one of those two. And I've got the opposite, so again this one's going to be sine. So we know that the sine of 25 is going to equal the opposite, what I want to try and calculate, over the hypotenuse, which is 20. Let's rearrange that. I can multiply both sides by 20. They'll cancel. So we get 20 times the sine of 25 is going to equal the opposite. Let's go to the calculator, and we've got 20 times the sine of 25 gives us 452, and I'm just going to round that number to something a little bit more useful, which is going to give me 8.5. And there we've solved another one. Let's look at one that is not a sine, but this time we'll look at a different one. I'm deliberately just drawing the triangles around different ways because the first thing we need to do is to try and work out what we want to work out. So I'm given a triangle and I'm asked to find x. We've got our angle, we've got a side, we've got to find another side. So let's start by writing down SOHCAHTOA, and then what we want to do is label our triangle. So hypotenuse, this one is the opposite side, and this one is next to the angle, which is the adjacent. The hypotenuse is always opposite the right angle, it's the longest side. Let's write down what we've got. So I've got an angle, I have the adjacent, and I want to find the opposite. So I'm not interested in the hypotenuse in this question at all. Angle, that's sine, cos or tan. I've got an adjacent, that means it's got to be ka or toa, and I've got the opposite, so it means this time it's going to be a tangent. So the tan of 22 is going to equal the opposite over the adjacent, which is in this case 16. Let's move the 16 over, so we'll multiply both sides by 16, and we get 16 times the tan of 22 equals the opposite. We'll go to the calculator and we can type in 16 times the tangent of 22 equals 6.464, and I'm going to round that to just one decimal place, so that's going to give me 6.5. I'm going to do another one of these, but this time let's try and find the adjacent, and this is going to give us a little bit more of a problem. So I'm going to cheat this time. We're just going to give ourselves a triangle, we're going to give ourselves an angle 28 degrees, and this time I'm going to have the opposite known. I know that this is 5 and I've got to work out what the adjacent is. We'll start with labelling the triangle. So the side opposite the 90 degrees, the right angle, and the longest side is going to be the hypotenuse. The 5 is here opposite the angle, and the angle, the side we want to find, is labelled here as the adjacent. Let's start with SOHCAHTOA. Now I already know this one's going to be tan, because I told you it was going to be, but we've got the angle, we've got the opposite, and we need to find the adjacent. So again, in this one, the hypotenuse is not going to be used. We know this is the tangent, so tan of 28 equals the opposite, which is 5 over the adjacent. And immediately I hit a little problem, because this problem is not the same as the previous ones. So I need to get rid of this adjacent, as we did before, so I could multiply both sides by the adjacent. So that's going to give me the adjacent times the tan of 28 is going to equal 5. Well, that's no help to me because I've got this in the wrong place. So to help us, what we're going to do is we're going to divide both sides by the tan of 28. These will cancel, and so what we've got is the adjacent equals 5 divided by the tangent of 28. Go to our calculator and let's put in our sum. So we've got simply 5. I'm going to do it this way. Yeah, that was good. 5, and I'm going to divide by the tan of 28. And up I come with my answer, 9.403, and I'm going to round that to 9.4, and there's my answer. So we can get these arranged in a different way. Let's do one more of those to make sure you're happy with that. Let's have yet another triangle. These are always right angle triangles, so you've got always the same arrangement. And I'm going to put in an angle. Let's say it's going to be 32 degrees this time, and I have this side, which is 8, and I want to find this side. Where we're going to start, we'll write down Sokotoa. Let's label our triangle. So side X is opposite the right angle. It's also the longest side, so it's the hypotenuse. This side here is the opposite, and the 8 here is next to the angle, so it's the adjacent. What have we got? We've got an angle. We've got the adjacent, and I want to find the hypotenuse. So I'm not interested in this opposite. Which one have we got? Well, we've got an angle, sine, cos or tan. We've got the adjacent, so it's either going to be cat or toa. We've got the hypotenuse, so this one is going to be the cosine, cos. So the cos of 32 is going to equal the adjacent over the hypotenuse. So my adjacent is 8, and that goes over my hypotenuse. It's the same problem as we had before, that we've got this hypotenuse, and what we did last time, we multiplied by the hypotenuse, brought it up there, and then we divided by the cos. Let's do all that in here. Hypotenuse, I'm going to multiply this by the hypotenuse. I don't want this cos, so I'm now going to divide both sides by the cos of 32. After a bit of practice, you can see that this is going to be the same all the time, and so I've got my hypotenuse equals my side divided by the cos of 32. Jump over to the calculator and we can put that in. So my hypotenuse is going to be 8 divided by the cos of 32. And that's going to give me 9.433, and we're going to call that 9.4. We've had a look then at several versions trying to find sides. Let's see if we can determine an angle. This time my angle is going to be x, and we'll have two sides. We'll have this side, which is going to be 3, and this side, which is going to be 6. My drawings are certainly not drawn to scale. Where do we start? Sokotoa. We label our triangle. This is the hypotenuse, it's opposite the right angle, it's the longest side. 3 is next to my angle I want to find, so this is the adjacent, and down here we've got the opposite. Where are we going to start? Well, we've got here the hypotenuse, we've got the adjacent, and we want to find the angle. I said that when we want to find the angle, we're going to use sine the -1, cos -1, or tan -1. We've got then sine, cos or tan. We've got the hypotenuse, it's going to be one of those two. I've got the adjacent, so it's going to be cos. So this is going to be cos to the -1 of my angle, and I could put in the equals, but I don't need to. We're going to put in instead a bracket, and here it's the cos, it's the adjacent over the hypotenuse, so it's going to be 3 over 6, and there's my sum to put in the calculator. Popping over to the calculator then, we want to do shift cos, so that's cos -1 of 3 divided by 6. I have to remember to press this arrow to put my bracket in and complete the sum, and we can then work this out, and it says this is the angle 60 degrees. Right, let's do another one of those. I didn't show you the answer, did I? No, 60 degrees. let's try yet another sum. And we'll have, first of all, our triangle. I want to find my angle. Let's have y for a change. And I've got, this time, 5 and 7. Let's put in the right angle. Here we go. So we've got SOHCAHTOA, and we could place these simply organised as the hypotenuse, the opposite, and the adjacent. What have we got? We've got an angle. That's what we want to find. And then we've got the opposite, and we've got the hypotenuse. The adjacent isn't going to be used in this sum. So I've got an angle, it's going to be sine, cos or tan. I've got the opposite, so that's going to be sine or tan. And then I've got the hypotenuse, so it's going to be sine. We're finding an angle, so this is going to be sine minus 1 of the opposite over the hypotenuse. My opposite is 5, my hypotenuse is 7, and we'll go off and work out this using the calculator. So we've got sine minus 1, so shift sine of 5 divided by 7, close brackets, and there I did make a mistake. I've got to press this arrow to put in the bracket, and there we go, we can work it out. And my angle is some 45.584 degrees, and if we round that, that's going to be about 45.6 degrees. There we are. So I hope that's given you an idea about some of these. The one that I haven't done is the tangent, so let's just look at that one for completeness sake. I've got a right angle and we've got a couple of sides. Let's have 9 and 10, and I've got an angle. We'll find the angle y again. So we start with SOHCAHTOA. We've got an angle we want to find. This side here is the hypotenuse. The 10 is the adjacent, it's next to the angle, and the 9 is opposite. So I've now got the opposite and I've got the adjacent. Let's look at what we're trying to find. We're not doing anything to do with the hypotenuse. So we've got an angle, sine, cos or tan. It's opposite, so it's sine or tan, and we've got adjacent, so this one is going to be the tan. As I said, that's what I was expecting to do. We're finding an angle, so it's going to be tan minus 1 of the opposite over the adjacent, so it's going to be 9 divided by 10. Let's go to the calculator and work this one out. So shift tan of 9 divided by 10, shift across with the arrow key, close the bracket, and we have our angle of 41.987, and that's going to give me an angle of 42 degrees as I round it. We've looked at then trying to do Pythagoras, and we've tried to use all of these sines, coses and tangents in different ways so we can work out how to do them. They're not that difficult. Where we have some fun with some of this is where we want to try and solve some problems. And of course, this is what always causes the grief in exams, which is trying to solve problems. So we'll have a look at some of those another time. And until then, I'll see you next time. Take care, stay safe. Bye bye.